All right, in 4.3, we talked about our first shortcut being side, side, side. For the first time, we were able to just show that if we have three sets of sides congruent to three sets of sides, then our two triangles would be congruent. Taking a look at our opener, if we were to do this as a proof, right? Some of the things we know, we start with our given. We know AB is congruent to CB. That's given because it's marked. We know that AD is congruent to CD. It is also given because it's marked. Now, what my first shortcut says is that if I have two sets of sides, all we need is our third set. That third set then that is missing here. In the left-hand triangle, it is side BD. And in the right-hand triangle, just so happens it is also side BD. So as for why BD is congruent to BD, anytime we are saying something is congruent to itself, it is that reflexive property. Right? So there's our opener here. Today we're going to take a look at two other shortcuts. The first shortcut is known as SAS. We swap out one of our S's in the middle for an angle. So for SAS, something very important here, the order does matter. This angle must be in between our two sides. So if I have side RS being congruent to side UV, and then side RT congruent to side UW. Then the angle that we are most concerned about is what they call the included angle. It must be the angle in between these two sides, the angle where these two sides intersect. So if I follow my two sides down, there's one, here's the other. Where do they meet? They meet at this angle right here, which is angle R. Your other set, where do they intersect? Where do they meet? That's the angle that is the included angle. So that is angle U. I do not want an angle that is outside those two lines. Right? Meaning if I go to mark these, I do not want this angle over here marked. Because now we have two sets of sides, and instead of having the angle that is the included angle in between them, we have one that is not in between them. Right? SSA does not work. It is not one of our 5 that we're going to go over this year. Right? So it has to be that included angle. I want that marking at the top angle here instead for SAS. That's what does work. Right, now there's a little error. If you're taking notes in the picture, or if you're taking your notes with our note packet, there's a little error in that picture. Somehow it got contorted a little bit when it was changed into a PDF. So I'm going to have you redraw that picture so that it looks like this instead. Now when we go to do our proof, once again we start with our given. It says given that JN is congruent to MN. So that was given. Second thing that was given, they give us that KN. Oops, sorry, hold on. Where did JN is congruent to LN. Sorry about that. There we go. JN is congruent to LN because it's both the single tick mark. Second thing we have is we got KN is congruent to MN. That is also given. So right now, we have two sets of sides. Option 1, for SSS, we would need a third set of sides. We would need a reason why JK would have to be congruent to LM. Option 2 is we could look at SAS. Meaning I need that angle that is in between my sides. So that would be angles 1 and angle 2 would have to be congruent. Luckily, there is a reason why angle 1 will have to be congruent to angle 2. Those are what we call vertical angles. And vertical angles are always congruent. That will make our two triangles congruent. Triangle JKN is congruent to triangle LMN. As for our reason, which reason did we use? Whoop. Well, that was SAS. Now, speaking of that little congruency statement that's there, I just realized that when we did that little beginning part, I forgot to put our congruency for our triangles. If we name the first one triangle RST, then the second one will have to be triangle, well, U matched up with R to S matches up with U to V, and then R to T matches up with U to W. So we have to make sure we have it in the correct order. So triangle RST is congruent to triangle UVW. Right. In example 2 then, it says use SAS in our properties of our shapes. It says in the diagram, ABCD is a rectangle. It says what can we conclude about our two triangles? If it is a rectangle, then AB is congruent to CD. Opposite sides are congruent. Likewise, AD is congruent to BC. Once again, opposite sides are congruent. So right now I have two sets of sides being congruent. I can either talk about the third set of sides being equal, meaning AC would have to be congruent to, well, the other one's AC again. Well, AC is congruent to AC. That's our reflexive property. So then these two triangles are congruent because of SSS. We could have also said, looked at SAS instead. For SAS, I would need a set of angles between our sides being congruent. Angle D is congruent to angle B. So that would give us SAS for the triangles to be congruent. So we can say that triangle ABC is congruent to triangle CDA. And then it's up to you which way you would want to do it. Do you see the reflexive property and using SSS? Or did you see that angle A and angle D are both right angles? So they have to be congruent. And then I have SAS instead. You don't have to do it both ways, just one or the other. All right, take a look at example 3 then. Example 3 says, in the diagram. That's a big old diagram. So let's just start with our given. I'm going to write it down, and then we'll go through and mark it. So in the diagram, CD, AB, and EF pass through the center M. Second thing we know is angle 1 is congruent to angle 2, is congruent to angle 3, is congruent to angle 4. So those are all given information. They want us to prove triangle DMY. So that DMY is congruent to triangle BMY. So that's this triangle here. All right, so we got angle 3 being congruent to angle 4, but we don't have any sides yet. However, one of the things we should always look for is these two triangles do share a side. They share this side, MY. Anytime two triangles share a side, I can say that MY is congruent to MY. As for the reason, that is always our reflexive property. So I'll go through, I'll put my tick mark on it. So right now we have an angle and we have a side. I need the other side. But the side I need to keep in mind. If I do dy, that's not going to make angle 4 the included angle. I do not want to talk about dy. We want dm. So we want to find why dm will have to be congruent to bm. Well, as it turns out, M is the center of our circle. That means that M to D and M to B are both a radii of the same circle. Radii are always congruent to each other. So I am allowed to say that DM is congruent to DM. My reason, they are radii of the same circle, or definition of a radius, property of a radius. You just have to identify that those pieces are radii of that circle. If I look at my markings then, we now have side, angle, side. So these two triangles are going to be congruent because of side, angle, side. That was triangle DMY is congruent to triangle BMY. And that's what SAS is going to look like. Which is going to bring us to our third shortcut. Third shortcut is going to be known as hypotenuse leg. Right? Hypotenuse leg is going to be in a right triangle. A leg of a right triangle are the sides that are adjacent to the right angle. So they're the two sides that make up your right angle. Hopefully by now we know what a hypotenuse is. Your hypotenuse is the side that is opposite the right angle. Now we have SSS standing for side, side, side. SAS standing for side, angle, side. And now we're going to have what they call HL, standing for hypotenuse leg. Now when we look at HL, HL does only have two things written there, an H and an L. So you need a marking on the hypotenuse and a marking on the leg. However, there is a third piece that you need. A hypotenuse only exists in one type of triangle. So we will have to have that it is a right triangle also. So you need to know that there's right angles, if I could ever get this thing to go away. There we go. If the hypotenuse and a leg of a right triangle. So you need a hypotenuse, a leg, and you need a right angle in order for this to work. If the hypotenuse and leg of a right triangle are congruent to the hypotenuse and the leg of another right triangle, then the two triangles are congruent. This is the one time where the angle does not need to be in between your two sides. It only works if it's a right angle. Right? Which brings us to our last proof here of the day. Right? In the diagram, it says you are given that AC is congruent to EC, AB is perpendicular to BD, ED is perpendicular to BD, and AC is the bisector of BD. I wrote all that down here for us. So those things are all given to us. AC is congruent to EC. I have that marked in the picture. Now they tell us AB is congruent to BD. What does that mean? Well, that means then that angle B is going to be a right angle. Likewise, ED is perpendicular to BD. That means angle D is going to be a right angle. So angle B and angle D are right angles. Well, how do we know that? We knew that because they told us that these lines were perpendicular. So we can say property of perpendicular lines, definition of perpendicular lines. Typically when it is a word that tells us it has to be true, we say it's the definition of whatever that word was. So I'm going to go up, I'm going to put these right angles that are up here. B and D are going to be right angles. Now, for side, 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 we have one set of sides, but we don't have any others. For side, angle, side, We do have one of the sides, and we do have a set of angles being congruent with B and D. I don't have my other side, however. Right? So let's look at the other piece of given information that they give us. They tell us AC is a bisector of BD. That term bisect means you're going to cut something in half. So this segment BD says AC is a bisector of BD. So AC is going to cut that segment in half. So this piece on the left will be equal to this piece on the right. So BC will be equal to DC. For our reason, what told us that? They said that AC was a bisector of BD. So once again, that word bisect told us that. So it is going to be the definition of, in this case, it was that word bisector that told us. So if I look, go back into my picture, we now have two sets of sides, but we don't have the third set. We do have two sets of sides and an angle. However, that angle is not in between my two sides. That angle should have been here and here for it to be SAS. The new one we talked about is HL, meaning it has to be a right triangle. So we have our right angle. The hypotenuse needs to have a mark on it, which it does. And one of the legs, not both, just one, that's why there's only one L there, needs to have a mark on it, which it does. So this is HL. So our two triangles, they are going to be congruent because of HL. And then we just named those two triangles. It was triangle ABC. It's congruent to triangle EBC. And there's our homework here.